Welcome to the last video in our three-part series. If you're starting here, just know that we are building on concepts that we outlined in the earlier videos. So if you feel like you're missing something, please go check those out. If you've stayed with us through all these videos, thank you again. And we're excited to see how you use the Splunk app for Chargeback to get in control of your SVC usage. In this video, we will be focusing on how you can use the Chargeback app together with Splunk's inbuilt workload management capabilities to identify SVC hoggers, i.e. any kind of wasteful uses you have across your deployment, and how you can tackle them and take proactive steps to manage your investment going forward.
Thanks, Venu. So now let me show you what we talked about during breakout sessions at Conf. So if you guys remember, this was our presentation from Conf when we looked at the optimization aspect of what we can do and how you leverage workload management. We discussed there was a couple of scenarios, examples that you can use to set up to get WLM started. By the way, this is just easy to find. Just do Splunk space workload management. It will take you to this site here. And there are actually two examples right at the bottom here. Look at managed search workloads in Splunk Cloud Platform, workload management examples. And there are two scenarios, okay? So I'm gonna, actually three now. I'm gonna walk you through how I actually used some of these scenarios in my lab. So first, let's see what our options are. Okay, so pretty much we have three different things that we can do. We can actually just issue an alert, detect something. For example, long-running searches. We can detect searches that are going after all time or after all indexes. It depends on the situation, on any use case. I kind of like to have a nice message in here. So this, all it's going to do is going to display a message, but underneath the covers, it's actually creating an event or an alert, which we're going to intercept. Okay, this is what we're going to be looking at today in this video. So that's the first option, right? So that you can actually at least start knowing what's going on and what's happening in your stack. The second option, which is I kind of like, it's more for ad hoc users. It would actually, you can actually queue their bad searches. So say, for example, they are they're issuing or searching something all time or looking at a lot of data and it's long running. We can actually come in here and say, in this situation, I want you to queue these ad hoc searches, and it will, after they exceeded 50% concurrency limit. Okay, so we can actually say, if it exceeded this much, I want you to go in the queue, and it's described well in the documentation what's going to happen. Now, workload is going to find the right opportunity to rerun these searches so it doesn't overwhelm your platform. So sometimes another cool thing that you can do, we didn't stop the search, we didn't do anything like that, but we only took action here in reducing the impact in on the platform, maybe during the day, so that's where the schedule comes in. You can do that maybe 9 to 5 during the day. After that, they can run these searches without any problem. But during the day, we don't want any other users to be affected by just simply bad SPO. And the third situation is where, I like this to be last. I've done this. I identified all the bad things. I took some action by queuing some of the searches, and then I can actually finally say, all right, I had enough. Now I'm going to stop these activities, right? I give you a chance to, fix your searches. Now going forward, you're not going to allow them on the platform, but we're going to have to be careful, and we need to make sure we don't affect our user community and we don't effectively disable any use cases, any searches, and some of them might be critical, like enterprise security. So we want to be very careful about this step. So I went in here and I actually implemented these scenarios. I'm going to show you how it looks like. So I jumped on an ES search head, and I went from settings. I clicked on workload management. You will find it in here, right there. Admission rules. This is where, from the get-go, You're going after every index. I'm not going to admit it. Just basically, it's going to stop it, halt it. That's actually this scenario. Okay, we're not going to do that. We're going to talk about this scenario here, or workload rule, which I created here. So I'm going to edit it and show you how I did it. Notice the order matters, which one runs first. So this is the only one enabled right now, and that's why you see one. So these are predicates, and you have multiple different predicates that you can use. In this case, I used 3. I used runtime. It ran for more than 5 seconds. And meaning at the same time, the user or the job, doesn't matter what type of job here, by the way, the search looked at every single index or search all time. Okay, so these 2 scenarios. This is where, how often it's going to run. This one, I recommend that you run it always to find fish for this stuff, right? To find it. It's going to display a message. It's not going to do anything else. Display a message. And this message here, we're going to intercept that message. And so to see where in the entire environment, I have this situation, okay? So all you have to do is just create that and then submit it, and it starts taking action right away. From this moment onward, we will start monitoring that. And if you jump on the Cloud Monitoring Console in your stack, click on Workload Management Monitoring. This tells you here, stuff that we filtered out, stuff that we alerted on. I'm going to focus on these 281 searches, right? At the bottom, we can see a list of them, right? So I'm going to pick on one of these, right? So I'm going to pick on unapproved port activity detected, right there, this one. Okay, so I'm going to go see what's going on. 109 times. Why is it 109 times? Because most likely this search runs every 5 minutes. So really, they're very aggressive. The most aggressive SVC usage searches, they are the enterprise security searches, because they're trying to search a massive amount of data to find what they're looking for. So now watch. So now we're going to go grab this here. I'm going to use a Chargeback app to kind of find it. So I basically went into the Chargeback app. I clicked on reports. I open up the filters. I clicked on basic. Basic filters would, you can just pick your ES search here if you want to just zoom in on a search. You don't have to. And in advanced, to zoom in on the job, right? Because this is what we're going to be looking at. That's the name of the job, unapproved port activity detected. And so here's the information about this. And as you can see, how much SVC is used overall, it's not terribly bad. Remember, this is a lab environment. So the amount of data it looks at is not as much as it would in your environment. And it looks good. However, this is just an example of what we're trying to do here. Now watch this. You see here the list of indexes it went after. It's not clear to us what's going on here, right? Why did workload management flag this, either looking at every index or searching all time? Why did it do that? It's kind of confusing, right? When you look at this, and I don't see any reference to all indexes here. What's going on, right? And by the way, it only looked at, like you see, this is the time range it ran. So it's not terribly bad. It didn't actually execute all time. So most likely, it's trying to search every index. That's what I'm guessing. Okay, so we're gonna take that search name. We're gonna hop on the enterprise security search head. You just not log into it, and then we're going to just find it here. You can just start typing port activity. So here it is, prohibited port activity detected, and then here's the search. Notice from data model, the data model is network traffic. I'm going to take this. I'm going to copy this and run a quick search here to see what's going on. I'm going to paste it in the search prompt. Doesn't matter where you do that, as long as it's on the enterprise security search head. Command / formats the search. Shift Command E on a Mac or Shift Control E on a PC will expand the search. Okay, now notice what's going on here. Now, finally, I'm seeing why workload management is complaining here. Why did it issue? There we go. It's actually worse than I thought. Not only is it looking at every index, it's also looking at every internal index. Okay, I understand it's going to use these two fields, but still a terrible idea, right? Because most likely this information is in your Paolo or your ACS, you know, in your firewall logs. We know exactly what indexes are these. We could have done a better job, right? So now that I actually seen where this is coming from, let's go see why did this happen. Okay, so we're going to go to the network traffic data model and configure SIM setup. This is a tuning every customer should make sure SIM is actually tuned, because otherwise there will be a lot of wasteful usage that you don't want that to happen. So I'm going to scroll down and find that network traffic. What I expected to see here is like in a list of indexes. Second, allow list for indexes. Okay, you can edit it. This is a macro. Underneath the cover, this is driven by a macro. So you can, if you want, do it from settings, but actually like to do it from here. So if you have an index called Paolo, you start entering a list like that, Paolo, it will find the index, then comma ACS, whatever that's Cisco ACS, right? You know where they are, you know where this information for the network traffic data model is located. You just create a list of indexes, and that would actually help a lot, because now this data model is, when it accelerates, right, it will make sure it only looks at these 2 or 3 indexes in your environment, not every single one. So blank doesn't mean it's not going to look at anything. It means the opposite. It's going to look at the whole world, which is a terrible thing. We don't want that. So now going back for full circle, right? So we now use this method here. I kind of like to call it detection alerts, right? We use this and to find these hoggers or high SVC usage. Potentially anything that looks at every index and all time, it's going to consume more resources. That's without a doubt. There's no question about it, right? So now I'm going to show you something else. We're done with this scenario, and please try it out in your environment. Really easy. If you have any questions, just email us. I can send you more screenshots. I can send you exactly how I created this. Again, you can see it's very simple. Here's what I wrote in the predicate conditions. I'll give you an example here. All the predicates available to you right there, and just put a message so the user will see it when they run their searches. So,
AK, I'd like to offer some experience with these workload rules that you've discussed and provided examples for. At FedEx, we've used these simple rules to ultimately eliminate inefficient searching just through ad hoc searching. It's been very efficient for us, and it's caused a lot of spikes within SVC usage to go down. And it's been very impactful through our environment. I would highly recommend using these rules to do just that. Just cater them specifically to your environment and what you see on a daily basis. And I believe you'll see great usage from this resource.
Thank you, Zach. Oh, another good thing that I like you guys to look at is placing the workload in a different pool. Okay, so we have 3 pools that we provision in Splunk Cloud for every Splunk Cloud customer. We provision one called high performance, limited performance, and silent performance. If it's something that is wasteful and you still want to run it, okay, say it's a scheduled job, it's important. You can say stuff like that. You can say not role equal ESS admin. So skip the ES stuff, right? Don't touch the enterprise security search if you're worried about it. You can do that. But then you can say, well, I want to place that in a limited performance. It will still run, but it's not going to use the same amount of resources. It's going to be limited to what it can use, right? So it might impact the environment less in that case. So that's another cool option for you to look at. All of this is actually in the examples. They walk you through the whole scenarios in here. It's mentioned in here what you can do with these with workload pools. So now I'm gonna switch topic to another app that my team developed called the Insights app for Splunk. It's found on Splunk base. You can install it in your stack without opening any support tickets. You simply just search for it, IA4S, and you'll find it, install it, follow the instructions. But you can use ODS to help you deploy it if you need some help. So I like this because it actually ships with a lot of cool stuff admins appreciate. So this is the home page of the app. The landing page is like a search repository. Okay, so this search repository is on top of all the dashboard that the app ships with. We're going to look at a couple of them that are important to the topic that we're discussing today. So first, I want to show you how to use the repository. Okay, so everything is categorized here, tags. So you can look for maybe a tag called health to check on the health of your stack. So this is one of my favorite searches, right? So we have spent all this effort. Okay, let's go back to the ES. All this effort to accelerate all of these data models. That is a huge amount of effort to accelerate them. We at least think or believe or hope that the security team, when they write their use cases, they will write them properly using T-stats summaries only equal to true. So let's see a properly configured use case. Okay, so this is how they should be written. Let's look at it. One. There's it, right? Beautiful, right? It starts like that. It goes after the accelerated data set. It runs and screams performance. That's every ES use case. Almost, sometimes you can't, right? You can't, that's fine. But everything that you're able to use T-stat summaries only equal to true is very important because that would speed up the searches. It would put less impact on the platform. Think of it as we're going to an ocean. We're grabbing all these events that you need to be searching all the time, and we're grabbing them, we're putting them for you nicely in a smaller data lake. Okay, I like to call it a data lake. So we've done all this hard work, so you don't have to do it again, right? So we don't need to go back and search every index. We've done that work. We harvested them, collected them, and stored them for you in that summarized data set. And so you should be writing your use cases accordingly, right? So now, on the ES search head, really easy. When you don't have to write the search, by the way. As I said, you just click on it. That would run it. I just change your time here to last 24 hours. So let's run this and see what we have on the ES search head. We can actually zoom on the ES search head. Sorry, I could have done that. This would zoom on the ES search head and only the ES search head. Let me see. It might be called something different in my lab. All right. Maybe not. I'll erase this from the recording, no worries. Oh, it's actually called ES. Okay, so we can zoom in. Repeat, we can zoom in on the ES search head. So the way to do that, it would be for Splunk Cloud customers, it would be called just ES, or you can just do star ES star like that. That will find it. So I just zoomed in on the enterprise security search head, and I found 332 scheduled jobs. See, scheduled. They are scheduled. They're running for sure. We don't care about stuff that is not scheduled. We're not going to fix that. We don't have time to fix everything, and nobody disabled it. So I kind of like these two together, right? It's not disabled and it's scheduled, meaning it's effectively speaking, it's running, alive and running, most likely runs every 5 minutes. So now, with a simple search like that, I'm able to identify these searches, and let's take a look at them, see what you think. Look at this one, when event log security, right? This should have been definitely written against authentication data model, okay? Anything related to an event log security should have been doing that. Some stuff like this, don't worry about it, like the identity management, I wouldn't, that's a very tiny data model. I won't care about converting it to t-stats. You can if you want. Now, don't let these fool you, right? So in this particular example, this macro here, most likely, this macro is an index something, a list of indexes. So there's not, I can tell you this is not a t-stats for sure, right? You can tell really easily that it's not. So most likely going after indexes, and we could have found a suitable data model for this to run on, right? And we really, want to go after the big stuff, right? The stuff that goes after the security data. Here's more example. Look at that. More and more example of stuff that is going after Windows data. We want to make sure to use t-stats, right? Anything input lookup like that, or ignore it, right? We don't care about it because they're not going to put any impact on a platform, right? So in other words, you can very quickly, using this app, identify, and by the way, it has information about where it is, which app, what the name of the search head, what kind of job it is, alert or report, who created it, in this case, Ella, right? And by the way, you have this option to actually add business data here, which I love this, right? So you can add their department, you can add their business unit, right? All this information. imp_star would have all the information about this user. Okay, even their title in the org or email address. So you can quickly, here's your stuff, Ella, go fix it. This is how often it runs, right? So, this is just one thing that you can do. I like to show you a couple of things, and we can wrap this up. There is a dashboard that every admin should be looking at, which is your bundle analysis. Actually, you can get to it from here, from the Quick App. Quick Apps is like my favorite dashboards, right? So I want to show you this bundle analysis here. So the bundle is really important. We want to watch what's going on with that bundle, look at it, maybe alert on it, just make sure nothing is impactful, right? So look at this search head. When you look at anything related to bundles, make sure you look at one search head at a time, right? So the size is about 299 megabytes, not bad, right? But then we can quickly see what's in the bundle here, and the size in megabytes. What's the path to it, where it's actually located in the apps folder. Even KG stores are in the bundle, right? Even these, they get split into 10 meg chunks, and we put them in the bundle. That's why you see that's very close to 10 megabytes here. And so the point here is I can basically find anything that we didn't need in the bundle, and we can add that to the deny list, right? So you have the filters in here. You can go maybe just look at CSV files to get started. They're notorious for being huge. Maybe a data scientist accidentally created a CSV file. You don't have a deny rule, and all of a sudden he caused that bundle to increase double in size. Okay, that's going to slow down searches. That's going to cause problems. That's going to impact the search head, if not the platform, right? So I kind of like to do that, and just simply, if you need to set them an alert, open anything in search like so. You can set up first the filters, right? So you can say, well, show me, I want to see anything greater than 10 megabytes. I don't care about the small stuff, right? So do we have anything greater than 10 megabytes? Let's see if we do or not, right? So we found about altogether these above, and that's why I kind of like this. These they add up, right? So even if there were a few, but very quickly, because they're above 10 meg, all this small list becomes 200 megabytes, right? So I can then say, open this in search, and then save this as an alert. If this situation happens, send me this table so I know what's going on. So if somebody gone and added something to the bundle accidentally, most likely that's what happened, or they installed an app from Splunk Place that increased the size of the bundle, at least you'll have that awareness and see what's happening in your stack, in your environment. one last thing I want to show you here. So I can also look at all your reports in here and kind of dissect them, right? So for example, I want to go and see, but this save search on the ES search, what lookup is going after? This lookup is actually very large lookup. Is anybody using it? That's a common question, by the way, a common issue. We need to make sure before we touch that lookup, we need to figure out if anything is using it, right? So I usually launch the reports dashboard, number 2 here, and number 1, look for any dashboard that goes after that lookup. Then I'm trying to figure out what to do with it. And then right in here, you have what we call reference filters. You see that in here. So we can enable the reference filters. And this first one on the left here, all of the lookups and how you're interacting with them. If you're inputting from them, if you're outputting to these lookups, and even if you're using the command from lookup, from input lookup or from lookup. So we can very quickly find out. We can also use wildcards too. So if you want to know if anything that you hunted here that are, nothing is using these CSV files, most likely you would find nothing here. And in that case, that gives you more, this is more evidence for us to figure out if we can actually disable these jobs or not, or disable that lookup or remove it from the search head, not disable the job, but disable or delete that lookup, right? Or write a rule to deny it from getting into the bundle. So that's just a quick example, and you can see here, it's the same thing for indexes that these searches are going after, right? All the different indexes, the different source types, the different sources, if they're using REST and the REST API, even event types and macros and all that good stuff. And then I can come down here and then I can start reporting that environment. I can say, for example, show me everything by a line of business, so or by by the business data we have in here, or I can say all the jobs and what indexes they go after. A lot of our stuff here in the lab goes after index internal because we don't have too much data. The lookups that they go after, I kind of like to look at several things here. The schedule, the current schedule, we can see how staggered, right? If we see something, this runs every hour, we have 195 jobs right on the hour. There's no skewing whatsoever. You can see that here. Maybe you want to do something about it, right? To help the stack a little bit. So kind of use a combination of these dashboards and the repository we told you about here together to monitor your stack, keep it healthy, and hopefully you will enjoy doing that because you'll have better experience at the end of the day. Thank you so much. Venu, you want to wrap it up or no?
I think it'll be good to have a wrap up at the end again. Let's see.
I can delete what we just said right now.
Do you want to do? I kind of assumed you are. So thank you everyone for sticking with us through all of these 3 videos. Hopefully this will give you the right tools and you're now able to get in control of your SVC usage across your deployment. As you're going through this, if you face any issues, please remember that we're always there for you. You can reach out and we can help you. Please make use of resources available to you like ODS to help you get started. Or if you have any questions, please reach out to any of us here on this call to answer any questions you might have. Thank you again.
Thank you, Venu.
Yeah, cut.
I'm going to stop recording. What do you guys think?